Okay, so good morning. So we will start. Yesterday we were looking at inverse problems in transient conduction. Okay, what happened? It's not 9 yet. 8:59. Okay. So we're looking at a plate which is initially at a temperature of Ti, which is cooling in cold surroundings. And there's a heat transfer coefficient of H, mostly natural convection, and there's a free stream temperature of T infinity. Okay, this could be just like there's a hot coffee on your table, the coffee is cooling down, or it could be the heat treatment of a ball bearing. Okay, or it could be a missile re-entering the Earth's atmosphere, or there could be a cooling of an electronics, okay, electronic equipment, or it would just be the cooling of the CPU of your processor in your desktop or laptop. Okay, desktop we use fans, for laptop we use what is called a heat pipe technology, where there is a fluid which changes phase, so there is a condenser, evaporator, and all that. Okay, so but eventually from the backside of the laptop, again heat is transferred by natural convection and radiation to outside. That is why the whole of the backside of the laptop will be hot, because there is a HA delta T. There this equation will still be applicable. All right. Okay, now integrating it, and then you're getting a form which is close to linear regression. All right. So then what you can do is you can convert into ln, and then when it is ln, it becomes linear regression, just like this. Okay, and then I've written the equivalent of y, b, and a, and then you can plot ln theta, and then first you can do a visual best. And I just sent you a message. Just keep a graph sheet ready. So after Suraj dictates the problem or shows the problem, you can try the visual best for a problem. Okay, is somebody copying this, or can I erase it? How many of you, even if one person says I'm copying, I'll wait. You have to just speak now. Anybody still copying? Hello? Copying. Okay, fine. I'll wait. Let the others join. Today, is it okay? The board flickering and all that, is it okay? Somebody should speak to me. Is it okay? The top is visible and all that?
Yes, sir.
Yes, sir. Yeah, who is Professor Balaji, man? I thought I am Professor Balaji.
Suraj, sir.
Oh, Suraj. Suraj is using my laptop. Okay. So, okay. Lockdown effects. His laptop up. So I gave him my laptop. Of course, my laptop is this. There is one more laptop, Apple Mac I have. So I kept it at I was using it at home. We have a Sony, what is that called? Home theater. That day some English movie, my daughter was seeing it. The speaker, it created so much noise, it fell down. The screen broke. Looks like it's 10,000 rupees. That's okay. It's not easily available. So I've given it to a local vendor. So freak accident. So some 10K it will take 1 month to get it repaired. Okay. Otherwise, I don't have one. Suraj is using one laptop, and this one I'm using for the class. Anyway, I have multiple desktops I'll manage. Can we proceed? I have one desktop at home, one desktop here. Done. Very good. Okay. Let us look at a slightly harder variant. Okay, so this is the plate. That is okay, huh? L. Okay, there is a plate which is at TI. Okay, it has got dimensions of LWT, length, width, and thickness. Mass VP. It is aluminum plate, but now situation has changed. It is in outer space. In outer space, there is only vacuum. If there is vacuum, what is the value of H? What is H?
0.
0. Manthan.
Yes,
Are you
sir.
there?
Yes, sir. Yes, sir.
Is there any hope for the plates now to cool?
Yes, sir. Radiation, sir.
Exactly. So there is hope. Okay. So hope is very important in life. Even during COVID, you should not lose hope. See, after 1 year, whatever it is, vaccine has come now. Okay. Good or bad or something, it's better than water, right? So it's better than a vitamin injection. So when the chance comes, you guys should also take. Okay. Anyway, now let's say this is epsilon. Okay. Now I will say this is T infinity. Okay. Now MCP. So this is small body kept in large surroundings. Okay. Otherwise, these U factors and other things will come, which I have taught you, right? Or some other prof has taught you if you're an MTech student. Okay. You can watch my radiation lectures, even if somebody is not studied in IIT. You can watch my conduction radiation lectures on NPTEL. Okay. And there I have talked about U factor, blah blah blah, in one of those lectures. Okay. Now this is going to be tricky. Huh? Is it okay? The right side is easy. You can do that. Huh? Right side is no problem at all. Left side. What is missing? Half.
Sir, 1 by 2 infinity, 2t infinity square.
I don't understand.
The T infinity square is also
1 by
Wait,
2t.
Let us do it. Don't worry. So is this correct now? Is this correct? Huh?
Yes, sir.
Now method of partial fractions. Into 1 by so this is
2T infinity square.
1 by 2t infinity. I left the 2 infinity. Let us check. T square plus T infinity square minus T square minus T square minus T infinity square is plus 2T infinity square. Therefore 1 by 2 infinity square will come. So okay. So regardless of whatever you say, I have to get convinced. So it is okay. I think it is good. Okay. So okay. Now 1 by Again. Okay, now there is a potential for me to make mistakes. Just tell me whether it is okay. It's okay. Any mistake? Yeah, somebody should speak. Yeah, somebody should tell me. Am I audible?
No, sir.
I'm not audible.
You are audible, sir. Like there's no mistake.
There is no mistake. Okay, okay. No. Now please integrate this. Please integrate this. So 1 by 1 by t infinity is so I have this in order to save time. Ln of t minus t infinity by ti minus t infinity minus ln of t plus t infinity by ti plus t infinity minus 2 by t infinity square tan inverse of suppose I give it in the exam, you will be floored. This is the forward model. On this, if I give the inverse model, end of story. Huh? So I don't want you to think that okay, sir is again saying a plus bx, linear equation. It's not that. Once you get into a heat transfer problem, a simple plate can give so much trouble. Just take the plate to outer space, it can give so much trouble. Okay. So please clean up that. I might have made some minus plus whatever that you know that this is a ln of, this is tan inverse of. So 1 by a square plus b square is tan inverse of all that, you know that, and this is ln of. Okay, you can do all that. So I just erase the left side. Okay. So suppose I measure, suppose the plate is cooling. Okay. Okay. So at some 6 values of time, I have the temperature measured. Even in order to get the residual, I need to find out the temperature at each of these times using simulation. What is the unknown here? What is the unknown? The unknown could be the emissivity in the problem, because we don't know what is the emissivity of that surface. Okay. So why do you take the trouble of doing this? Array, so look beyond. So this is basically, if the emissivity, you are in doubt, you are in ISRO, you are designing something. If you are in doubt, you would have done some design calculation based on that emissivity. You don't encounter the temperature in your lab, but the satellite has started working. It is getting data. From that data, you can do what is called post-quantum analysis, and then you can invert the emissivity and just say for the next mission, you will use this emissivity. Back in the ground, what you can do, you can have a vacuum chamber, and then the vacuum chamber, that could be a spherical vacuum chamber, which is there in the heat transfer lab. Suraj is Suraj. Can you make a video of your this thing? So you know how to make a video?
Yes, sir.
So you make a video of the vacuum chamber and speak, and then
Yes, sir. Vacuum chamber actually I'm in experimental room, sir.
he is in experimental room. Okay.
Yes, sir.
Suraj.
Yes.
Now can you show that? Can you zoom? Can you?
Yes, sir.
Yeah, that vacuum chamber you can see at the back.
Yes, sir.
So okay. That is, do you have a stick, Suraj?
No, sir. I don't have a.
Can you zoom it or something? Can you take the laptop there? No.
Yes, sir. I will take.
Ah. This is the heat transfer lab, ground floor. So
Yes,
6 professors have 6 experimental rooms. Our students sit there. You see, it is fully equipped. He has a split air conditioner.
I open, sir. Vacuum chamber.
Hey, what is that blackboard? You also have a blackboard there.
Yes, sir.
Oh, very good. Okay.
Yes, sir.
Show it, zoom it, and explain to them the vacuum chamber. Okay, that is a vacuum chamber which was built by Hindivac, Bangalore. See, there's so many contraptions, so many wires, and
This is my
thermocouples.
test sample, sir. I'm doing.
Yeah, Suraj, I'll keep quiet. You explain your vacuum chamber for 2 minutes.
Yeah.
Speak.
This is a vacuum chamber. This is interior portion of the vacuum chamber, and inside the interior portion of vacuum chamber, I kept a test sample which I am doing experiments, and this is a heat sink. I am doing as a temperature as a 10 degree to minus 9 degree Celsius by Julabo. This is Julabo. Okay.
Julabo is the German equipment for low temperature
And
bath.
down
What is
is
the
a
minimum?
pump.
Yeah, what is the minimum temperature, Suraj? The Julabo?
minus 9 degrees Celsius.
Minus 9 degrees Celsius. Okay, so we can go only up to 265, 264 Kelvin. If you want to go further, you have to use a liquid nitrogen pump. And so that facility we don't have here. You have to go to ISRO Bangalore.
Yes.
Proceed.
Yeah, this is pumping system, and using pumping system, I made a high vacuum inside the vacuum chamber, approximately 10 to the power minus 7 millibar.
See, 10 to the power of minus 7 millibar.
Yes, sir.
We are reaching super duper low pressures.
Okay. Yes, sir. Like this one, sir.
Yeah,
And,
okay. Okay, Suraj, thank you. So I will call you again. Okay, very nice. So it's good that. See, Suraj now is staying in Velachery 7 days a week. He's coming and he's putting fight. He'll bring his dabba. He's in a PG now. So he doesn't like sambar, but I think they give sambar and rasam. Okay, you can switch off the video, Suraj. Get the presentation ready. All right. So the funda is, you look at what Suraj has done. Based on this, you can have a method to determine emissivity using Bayesian. That's what we did. And what is a big deal? Emissivity is not known for many substances. So we did a project. ISRO gave us 30 lakhs. There was a PhD student who came out of this, and now Suraj is doing part of his PhD. Emissivity is a function of temperature to low temperature. Where will you get? Google will not give. Who will give you? Because it is very specific requirement. Who wants emissivity at 150 Kelvin or emissivity at 200 Kelvin? Only a space agency will want. You need. There should be a need for this. Okay, and only Indian scientists can do it. Okay, so we have to, some professor in India has to do it. So we did this work, and now this can be used as a technique to get emissivity. All right. Now let us make it a little simpler. Let us make it a little simpler. T infinity can be taken to be outer space. Outer space can be taken to be 3 Kelvin and approximated to 0 Kelvin. Once you have that, so this is possible only if the satellite or the plate is not facing the sun. If it is facing the sun, MCP dt will be equal to minus epsilon sigma plus some Q, that is the incoming solar radiation. Then, so you have to find out, this has to be positioned in such a way, the satellite or whatever antenna or this equipment has to be positioned in such a way that it is not facing the sun. All that you can figure out if you do all these planetary all these calculations, right? Orbital, this thing, and then position and all that. So if you are in the satellite project of IIT Madras, you would have. I don't know if any one of you is in the satellite project of IIT Madras. Huh? No. Okay. All right. Okay. MCP dt by delta equal to minus epsilon sigma t to the power of 4 minus t infinity to the power of 4. This is 0. Class, please take 5 minutes and crack it and get the solution. Crack this problem. Yeah, solve this problem. Solve. Is the question clear? At least tell me the question is clear. Is it clear? Array, somebody should tell me it's clear or do a thumbs up.
Yes,
Okay,
sir.
fine. Yeah, please crack it now. And if somebody has solved, you can show the paper to us. You can pin his video and then they will speak instead of me speaking. An opportunity for somebody to speak. There is so much shake in this shaking. I asked you a question on the chat box. At least one of you should respond. 80 people are there. 77. Yes, sir. Very good. And if somebody has completed, you can just put a thumbs up. You will come on video and show your work if your bandwidth is good. Any luck? Any luck for anybody? Ah, class is seriously doing. That is good. If you are doing it, is good. If you treat it as a water break, it is not good. Anybody? Shalu, did you finish Shalu?
Yes, sir. But my bandwidth is very low. I don't
What is the
have the
solution? What is the solution?
1 by t cube is
1 by
equal
t
to
cube.
1.
Okay. Just so this theta doesn't work here, correct? Shalu?
Yes, sir.
Ah. What is integral minus? What is integral t to the power of minus 3?
So it will be t to the power of minus 4. So it will become
4. Yeah, this is 4. Minus 1 by 3 t cube.
yes, sir.
N plus 1 by n plus 1.
Yes,
Why
sir.
did, oh, this some long back I read in integral calculus. I studied. So this is Ti e equal to minus epsilon sigma a. But I won't lose hope. If I forget it, I will derive it. Okay. That's so I don't try to remember many things. Okay, 1 by 3. Okay. Okay, problems like this we'll reserve it for the end sem. Okay, so regression. Okay, so if it is, this will be a non-linear regression because you don't get a linear function. Try to put it as y equal to ax plus b. Y is equal to ax plus b will not work because it is t cube. Okay, so today we encountered the first non-linear problem in non-linear inverse problem. Okay, where this linear regression, life does not begin and end in linear regression. Okay, that's what you should know. All right, now can I proceed? Is the solution okay? R. Praneeth, Rajasundaram, Pratyusha. Anybody? Pratyusha A. Is it okay?
Yes, sir.
Okay, yes, sir. Okay. Order variant. What is this? What does this correspond to? The plate is losing heat by?
Convection and radiation.
Ah,
Convection and radiation.
convection plus radiation. Now, okay, then you have to take elemental slice. Minus Ka dt by dx at x. minus Ka dt by dx at x plus delta x. Therefore, the net conduction is delta x into this is W. Is the net conduction.
Sir, what have you written in the left-hand side?
Left hand side where?
Sir, just beside the diagram.
Where?
Sir, just beside the diagram.
Here.
Sir, yes, sir, just on the right side in bracket.
No, this is minus Ka dt by dx of x. I am saying you have to derive the Finn equation. Okay.
No, sir.
Convection
Like,
plus radiation.
oh, okay. I got it.
So convection plus radiation. Minus. Okay. So now I have to be very careful about this A. So the A will be equal to delta x into W. Okay. Into plus H. Net is minus epsilon sigma delta x. I'm doing it fast. I'm sorry because this was not the original intent. I didn't want to do this. Equal to MCP dt by theta. Okay. So MCP dt by d tau at that place. Okay. The unsteady part will still remain. But now, apart from convection and conduction, there is a net conduction which is taking place. Okay. So this becomes a harder problem. So for this, the forward model coding is required. I'm doing it very fast. Just don't take it as biblical truth. I might have made some small mistake, but the whole thing, the flow should be fine. What I'm saying is, what is the heat entering inside? What is the heat entering leaving this elemental slide? I'm considering like a Finn equation, and then heat is convected and radiated out from the left side and right side. So I have to do that delta x into maybe I have to do 2 because on the right side and left side here also maybe I have to do 2. You just take care of all that. But what I'm saying is now the equation is getting messy. The messiest of them all would be I want to find t is a function of x, y, t, x, y, z, and t. Okay. So instead of m, it won't be m, right? It will be rho. Okay. It will be rho into delta x. Okay. Rho into delta x into T into W into, okay, so you have to clean up. So delta x will get cancelled everywhere. So I'm trying to derive what we should do in 1 hour in 2 minutes. Okay, that is a problem. Okay, so this is not central to today's class, but what I'm saying is, you can just take a what is in a plate. You may ask, what is in a simple plate? My concept is from a simple plate, you can develop so many things. It is losing heat by convection. It is losing heat by convection radiation. It is losing heat only by radiation. It is losing heat in outer space. It is losing heat by convection radiation, but still inside conduction gradients cannot be neglected. There could be some heat generated inside. So this is how you develop the whole thing. So from simple, you can develop, you can march on to complex. Okay, but you should not lose track of what the core principles are. Okay, all right. Now, Suraj, so let's solve a problem. Now, what will be the problem number? What should be the problem number? Hey, Rajesh, Pawan is asking for attendance link.
Yeah, okay.
No, not okay. You have to send it.
I'm working on it.
Working on it. Okay. Suraj,
Yes, sir.
yeah, can you show it? What will be the problem number? Class, what will be the problem number?
Problem number.
No, Suraj, you
9.
may not lose, you may lose track. You may not be knowing. Class, what is the problem number?
9.
9. Okay. Okay, what I am going to do is, please submit as assignment. So, plus 10 will be weighted least square. So I am running short of time. So these two will be a take home. Okay, problem to be given tomorrow. To be given. And please note, tomorrow is the quiz. Tomorrow is the quiz at 12 o'clock. Please, we'll set up a link. Rajesh, please note it. Okay, Rajesh,
Sir.
please set up a link for submission of assignment test 2. So we'll do only only 2 assignment tests. The first is at Maruti Service Center, and this one. These two together will constitute 10 marks. 2 quizzes, 20, and NSEM is 50. Okay, let's be done with it. Okay, Suraj, just run through this question.
Yes, sir. I shared, sir.
Yeah, you shared. Okay. Please, so what you can do is, Suraj, you can send this question to them on the WhatsApp without the solution. Is that okay? Suraj, are you listening?
Yes, sir.
At the end of today's class, please send this problem alone without the solution to all the students.
Okay, sir.
Okay. So problem number 9, please take down. Consider the cooling of an aluminium plate of dimensions 150 by 150 by 3, all in millimeters. The plate loses heat. Attendance link has come. The plate loses heat by convection from all sides. Radiation is negligible. The plate can be assumed to be spatially isothermal. Ambient temperature is constant at 30 degrees centigrade. The temperature time response of the plate is given below. At 6 times, 10 seconds, 40 seconds, 80 seconds, 120, 180, 240. Some temperatures are given. There are 4 parts to this question. This is basically from the quiz paper, 2019 or 20, I don't remember. Set up the forward model. Determine the derive an expression for the temperature distribution. 3 with the data given. Do a least square regression. Get the best estimates of theta I and tau. Please note, yesterday somebody asked a question. No, I did not give the initial temperature. Okay, I did not give the initial temperature here. That means at time t equal to 0, you have to get it. So determine the correlation coefficient and all that. And then finally, we are saying this is material is aluminum. Cp 940, rho is 2700. And from this, get the heat transfer coefficient for the situation. Okay, this will be given to you. So this will be the. So you already know that theta by theta is e to the power of minus p by tau. All of you just take a graph sheet and convert this temperature to ln. Okay, so just convert the temperature to ln. Just take an approximate graph sheet, or if you're watching it from a phone, then go to a laptop or this thing, just take a graph sheet. Or you can get a graph sheet, you can generate a graph sheet on the screen, or you can use Excel, in which case the whole thing will become trivial. You can work out the solution in no time. Okay. So class, we'll have to solve this problem. Okay, first do a plot it and try a visual best. Is it clear? Okay, try a visual best. Suraj, is it possible for you to dynamically show a visual best?
Visual best, sir. First, I have to plot in graph, no, sir.
Yeah, you just plot in graph and show the plot to them. No?
Okay, sir. But graph sheet we don't have, sir.
Arey Baba, plot in Excel.
Yes, sir. Okay, already plotted, sir.
Yeah, but that you're telling the solution. I'm asking you only the raw data. Don't do with the solution.
Okay.
So just take it. So convert it. Class, please note down. Temperature, first you have to convert to theta, T minus T infinity. So the 6 columns of T must be converted to theta. X-axis will be time, Y-axis will be theta. Plot it after taking the ln of theta. Okay, Suraj. You see, Suraj is showing the answer. Hmm?
Just this
Hey,
is
don't give it to them. Don't give it to them when you send by WhatsApp.
yes, sir, this
Okay.
is
The font is too small. Can you see this? Okay. Okay. So why don't you try class? Why don't you try 2-3 points? You just plot. Just see whether whatever is getting 4.3, 4.2, all that is fine. Now try to get a visual best. Or you can just, after taking the lawn, linear, you just take a A4 sheet paper and plot it. No need for graph sheet also. Just take a A4 sheet and scale is enough. Scale pencil, A4 sheet should be enough. Could you show the question again? Very good. Okay. Suraj, somebody is asking you. Please show the question again.
okay.
Because I think they didn't copy the data. So 2 questions for the assignment. Okay, simple. All of you should be able to get 8, 9, 10 on this. So from the Maruti Service Center, many people did well. So this will be 10%. The passing grade will be only 30 marks for passing grade. Cutoff will be only 30 or 35. So nobody should have any problem. Can you make it bigger, Suraj?
Okay, sir.
Okay. All right. Okay, please copy down the data. So, quiz 1 tomorrow 12 noon. Please don't forget. It is not a fully take home, but it is not completely time bound. It's set for 50 minutes, but you have a time of 1.5 hours. 50 for writing and 40 minutes for upload. We will send you the question paper by 11:50 a.m. Okay, and you can start 12:50 or 1 o'clock. If you finish, then you can just check it. 1:15, 1:20, you just take pictures, put it into a PDF and scan it and send it before 1:30. The link will be set up tomorrow, and the question paper will reach you both by WhatsApp and by Smail. Okay, look out for both. Can we send it on Moodle also?
Yes, sir.
Okay, please send it on. So it will come on Moodle, Smail, as well as WhatsApp. Okay. And then this assignment is due on Tuesday. Okay. After that, we'll have it only in the maybe 3rd week of April or something, right? 3rd or 4th week of April. Because I want Professor S. Balaji to start something on neural network so that you practice something for the quiz. And the exam will be in May. All right. So how many of you are plotting? I'm not able to see you. Can you just say, sir, we are trying? At least I should hear 1 or 2 voices. Okay, wait, Pradeep Rajan, very good. See, you should try. Okay, Pradeep, Subhash, I'm getting the trend line, all that. Okay, fine. Okay. Suraj,
Yes.
some students are coming on chat and giving the trend line.
Okay.
Okay is fine. You respond to them. You just say whether it is okay or not okay to them and announce it in the. Okay. You have to announce like this. You have to say Subhash got it, and this is the, what he is saying. Like that, you just tell. I'm not able to see that.
Okay, sir.
Pradeep is doing okay. Subhash is saying something. Plus 4.242. That is okay. Subhash, what is the initial temperature getting? Okay, class. What is the initial? See, this problem is not taken from a book. You know that I have set it up. What should be the initial temperature from the guess, from your common sense? Hello?
100.
100, yes. So that is what I had in mind. But because of the experimental errors, you may not get 100. Subhash, you got 4.242. Just take the antilog of that. E to the power of 4.242 is how much?
So I'm getting 99.546.
Fine, very good, very good. That should be fine. You can work out the correlation coefficient. What is the tau you're getting? Point not 1. No, 1000. 1 by point not 1, right? That is tau.
Yes, sir. And
1000.
the correlation
Yeah.
coefficient is 99.24%.
Yeah, because it is all synthetic data, simulated data. Suraj, what is the time constant?
Time constant. 562 seconds. No.
562.
Yes, sir,
So we have to check
562
it.
seconds.
See, Subhash, you should reserve more decimal places. That's why you're getting point not 1. If it is not 15 or something, it will change. Okay, don't keep it as point. 3 decimal places are not sufficient. Okay.
Okay, sir. I will take it.
So you have to be very careful because they're all very sensitive to the number of decimal places you store. Suraj, show the data. Show the data. Don't show the answer. Okay. So Suraj, just take this question and after some time you just send it to them by WhatsApp, an email.
Okay, sir.
Or we can combine. You can just wait. Rajesh.
Sir.
So combine. We take this question. Take this draft from Suraj. Combine this question with my weighted least square question, and by today or tomorrow we can send it to them. Okay. Anyway, tomorrow they're taking the quiz. After tomorrow, so I will send you the question by tomorrow evening. Okay. The 2 questions. This is called the assignment test 2. So don't bother about it today. So today you prepare for the quiz. So after the quiz, we'll send it tomorrow. All right. Okay. We'll get it organized and send it together. Anybody got visual best or LSR? Anybody else? It's taking time. So somebody should tell me, sir, we are working, right? So somebody should tell me, sir, are you working? Hello. Please come on chat, tell me. Okay, Manthan says yes. And we should see some more people saying yes. Okay, so please note that this was a typical quiz question. So this was year before last or I don't remember which year. So something like this you will get tomorrow. Okay, I think it's time. So we'll stop now. Okay, so please complete this problem after the quiz, and you have to write it on A4 sheet and submit it as an assignment. Okay. So any questions? Suraj, you can stop the presentation. Okay. Any questions on least squares? So with that, we come to an end to linear least squares. So we will start with non-linear least squares. For example, this problem where we got 1 by t cube and all that. This y equal to ax plus b will not work. You need some other technique. We'll do that next week. Okay, we are going a little slow, but it's okay. But I think.
Sir,
Yes,
what are the portions for tomorrow's quiz? Is it until what you have taught yesterday or something?
Yeah, up to linear regression.
Yes, sir.
Up to linear regression. Okay, whatever I have taught up to yesterday. Okay,
Okay.
or whatever I've taught up to today, whatever. It's all right.
Okay.
Non-linear regression will not come. Don't get this. We won't stump you with some linear regression or this thing or whatever will come. Whatever you have taught so far, huh? Or power law or a polynomial, something like that, but not non-linear. All right. Okay. So see you tomorrow, 12 o'clock. Okay. 11:50. So I will not set up the Zoom meeting. How do you ask? You can ask doubts on chat to me. All right. So let's not set up a Zoom meeting. So the question paper will come to you. I'll be available on chat for the first half an hour. Suraj and Rajesh will be available on chat. Okay. So you can come on the WhatsApp group and then ask for any clarification. We already solved the problem. It should be fine. There'll be 2 questions. Okay. 50 minutes is more than enough. So the pressure of time is also removed because additional 40 minutes is available to you. Please upload by 1:30. Okay. So we'll see you at 11:50 tomorrow through the WhatsApp. Okay. Thank you.
Sir, how will the question paper be sent?
Question paper will be sent by WhatsApp and email and S-mail. Okay. That is so look for your this. If there's an internet connectivity problem, you go and sit in some other place so that you then for 1.5 hours again internet is not required. For uploading again internet is required. Is that okay?
Sir, for uploading, any link will be shared, sir?
Link will be shared. So this all worked out. Last 1 year we worked out all these things. We did many courses with this and this model works. Link will be shared by Rajesh or Suraj. Okay. Any other doubts? Okay, so we'll call it a day. Thank you.